Okay. Let me begin with reviewing what we learned in the last lecture. Okay. We learned basically Newton's second law. Mathematically, it's rather easy to write down Newton's second law, like summation of all the force acting on the mass induces some motion, or we could say momentum change. We sometimes write the linear momentum change with respect to time like that. And I suggest to you, the way to precisely implement the Newton's second law, correctly implement the Newton's second law, is to draw the Newton's second law, graphically express Newton's second law, right? And then invite the convenient coordinate and write down the equation and count the number of unknowns and number of equations. If it is the same, then we can solve it. Or if it's not same, then we have to invite some constraint which we did not recognize. Okay? And we showed you three typical examples to demonstrate how actually we can apply Newton's second law. The first example was there is a frictionless table. There is a mass which I call MA, and it is pulled by a taut string, which means that the string is not extensible, okay, and massless. Ideal assumption. It is, however, it is very practical if the total mass of a string is very small compared with the MA. It is very acceptable assumption. Okay, and this string will go over this pulley, and the pulley is connected another moving pulley that is connected like that, and there is another mass MB. And this floor is assumed to be frictionless. And we would like to know the acceleration of MA and the acceleration of MB. Okay. One possible approach to apply Newton's second law on this two mass system would be like that. Okay, one brave student attempt to solve or apply Newton's second law to this system by like this. Okay, first step, we have to find out all the forces acting on the mass. So there could be some normal force. Because the friction is very small compared with the other force, we assume that the frictionless floor, there is no friction. And also because it is present in the gravitational force field, therefore there is a force MAG, weight. And of course you can assume there is a tension, but he said instead of assuming tension, why don't we consider these two mass systems at the same time? Okay? Then there'll be some normal force over here due to pulley as well as some small friction. But it will go, extend, and there is a pulley, okay? And then there is a mass, MB. And this mass will exhibit some force, MBG, due to gravitational force field, okay? And that has to be equal to, apply Newton's second law. He said this should be MA, AA, that is the acceleration in this direction, blah, 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 and then this has to be go MB, AB. And then he argued that, okay, let's consider the force in this direction only. Say this is S direction. I am following the chord of the taut string. And I can say, okay, there is no force in this direction, right? Nothing. Except this. So I said MBG has to be equal to MAAA plus MBAB. And also he argued that because there is a constraint between AA and AB, or the displacement of mass A and displacement mass B, we note that XA has to be half of XB. Okay. Therefore, we can write AA is equal to half of AB. Now we have a two equation and two unknowns, so we can solve it. I think this is wrong. Why? Why? Okay, then you can solve this problem by considering each mass and apply Newton's second law. Okay, again, there should be some normal force acting on the mass A, and MAG, due to gravity, there should be tension 1. Two. Okay. Thank you. Huh? All right. Okay, that's very nice. And I have to equate this unbalanced force has to be expressed by mass times the acceleration of mass A. Okay, now there is another dynamic element, so moving pulley, massless. This tension has to be T1. Due to the symmetry, this has to be, the tension of this one has to be T1 too. Yeah? If this one has a mass, and later on, if pulley is very big, then T1, these two tension would not be same. Or if there's some friction, this T1 and this tension and this tension would not be same. But for simplicity, there is no friction, and the pulley is very small and massless, then we can assume that these two tensions are same. And also there is another tension acting on this pulley that has to be T2. Because we assume that the pulley is massless, this has to be 0. Again, I am emphasizing that we are applying Newton's second law on a pulley, massless pulley. And also, I can write here is another mass, MB, and it experiences some gravitational force field, and there should be some tension, T2, and that has to be equal to MB AB. Again, we use the constraint AA is equal to 2AB, and we can solve it. And my question is why the solution of these two approaches are different. Okay, the solution approach, follow or apply Newton's second law on each mass. This approach seems to us apply Newton's second law on two mass, and regarding the tension as internal force. What is the problem? Okay. The solution following this approach gives me the acceleration of A is equal to 1/2 divided by 1/4 plus ma over mb g, or if I simplify it, I multiply 4 on both sides will give me, this is 1 plus 4 ma or mb g. Does it make sense? If mb is very, very large compared with the ma, this is 0. Therefore, the acceleration of A will approach to what? 2g. Why? Why? Because there is a 2 code wrapping on the pulley. That is interesting. What about the then acceleration of B? The acceleration of B has to be 1g. Well, that makes sense. What if the mass of A, mass of B is negligible, is 0? Then what's going to happen? Acceleration of A is 0. That means that makes sense also, right? So it seems to me the solution I got is pretty okay. And if you plot the number that was given in the text, that is MA is 100 kilogram and MB is 300 kilogram, and if you plot those numbers over there, then you got the same result that you can see in the text. But this is a sort of the things I want you to do when you do the homework. So that is the last part, which I say enjoy the solution. Okay? Let me leave the question I gave you, why these two solutions are different. Let us forward to another problem.